Explored a form of pipelines in Delta Live Tables, which is pretty specific to working with our lakehouse and warehouse objects. Now we take pipelines in Azure Databricks to a whole nother level. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's embark on a journey into the realm of Azure Databricks workflow jobs, where we'll uncover the clues behind orchestrating, scheduling, and automating data processing tasks. We'll delve into job scheduling, automation, and the integration with other Azure services, all while maintaining peak performance and scalability. So put on your funny-looking detective hat, and let's get solving the mystery of the wondrous workflow jobs. Azure Databricks Workflow jobs provide the means to orchestrate, schedule, and automate data processing tasks. Imagine piecing together clues from different stages of data ingestion, transformation, and analysis to perform a cohesive process. These workflow jobs let you define, manage, and run multi-step data pipelines, ensuring your data operations are as seamless and efficient as a well-executed investigation. Integrated deeply with Azure's cloud infrastructure, these workflow jobs benefit from the platform's security, scalability, and compliance features. Let's break down a workflow job and look into its components. A job is the primary unit for scheduling and orchestrating production workloads on Azure Databricks. Jobs consist of one or more tasks. You can create and run a job using the job's user interface, the Databricks CLI, or by invoking the job's API. A job is executed via a trigger, which can be set on a schedule, by an arrival of a file, or can run continuously. A task represents a unit of logic to be run as a step in the job. Tasks can range in complexity and can be a notebook or any one of these other task types. You can control the execution order of tasks by specifying dependencies between them. You can configure tasks to run in sequence or parallel. As your job is executed, there are some additional components that require it to operate effectively and efficiently. Obviously, we need a compute to execute the job. These can range from serverless compute, serverless warehouses, and classic computes. Serverless computes are the default and recommended for most jobs, unless using a continuous trigger or time-based intervals, if using structured streaming. Computes can be identified to run certain tasks, and you have the ability to swap computes for different tasks. Libraries represent the packages utilized by notebooks or jobs. The scheduler manages job timing and execution. And the job's UI lets you see job runs, including runs in progress. You can receive notifications when a job or task starts, completes, or fails. You can send notifications to one or more email addresses or system destinations. Finally, let's not forget parameters. Parameters can be applied to the entire job or individual tasks, and can be static or dynamic. So what makes workflow jobs so awesome? Let's look at the clues. Azure Databricks workflow jobs automate complex, multi-step processes such as data ingestion, processing, and analysis, and can be scheduled using simple cron syntax for regular execution without manual intervention. Workflow jobs increase efficiency by reducing repetitive manual processes and facilitating collaboration among data scientists, engineers, and business analysts through shared workspaces and notebooks. They integrate seamlessly with Azure services like Azure Data Lake Storage, Azure SQL Data Warehouse, and Azure Cosmos DB, enabling a unified approach to data processing and analytics. Additionally, they support both batch and streaming data for real-time processing, essential for applications like fraud detection and live customer analytics. Azure Databricks workflow jobs are also cost-effective by dynamically scaling and using spot pricing options to optimize costs while providing visibility into job performance and cluster health with built-in monitoring tools. Now let's unpack the clues to deploying workloads using Azure Databricks Workflows jobs. First, start by setting up your Azure Databricks environment, configuring clusters with auto-scaling to optimize resource usage. Next, develop your task assets by creating and testing notebooks or scripts. Then package dependencies by managing libraries, ensuring all necessary external libraries are available. Moving on, create jobs for automation, defining tasks and setting dependencies within the Databricks workspace. Schedule and trigger jobs using the built-in scheduler or external events and API calls. Monitoring and optimizing jobs focuses on tracking execution, performance, and troubleshooting with logs. Collaborate and share notebooks, manage access, and integrate with Git for version control. Finally, ensure security and compliance by applying security policies, managing access controls, and using features for data encryption and audit trails. By following these steps, you'll efficiently build, deploy, and manage data processing and analytical workload solving capabilities using Azure Databricks Workflow jobs. Now that we've cracked the case to solving pipeline solution using Databricks Workflow jobs, it's time to put these to use. Let's fire up the Detecto Lab 5000 and put knowledge to practice. Welcome back, detectives, and here we're going to crack the case of workflows and pipeline jobs. So we've already worked with workflows in a sense with Delta Live tables, but now we're going to take it a step further and create job pipelines. Now, in order to preface this and set this up, just so you know, in my catalog, I have created a volume in my default schema named my volume so that these notebooks that have been created will land that data in that volume. So that's where the data is going to end up. And I've created these notebooks. So there's two different notebooks here. One is designed to load data, right? So what we're doing is we're sending out a request to a publicly available website to load CSV data in, right? So we're just going to land this data using a dbutils method to place this in the volume that I have defined here. The other notebook that I have created, that was load. That's the same one. Let's try to find a different one. This one is actually going to load this data into a Spark data frame called baby names. Then we're going to create a temporary view so that we can use SQL context in order to select the distinct year from that table. Once we have all the years, we're going to turn that into a list. So you can see that there. And then we're going to sort that. And then we're going to create a widget that's going to create a drop-down option for us to select which year to filter the data by. What we're going to do is we're actually going to parameterize this. And then when we run the pipeline a couple different times, we'll select a couple different year options, and it should produce a different output based on what we're selecting there. So that's the purpose of this. So what we want to do is go into workflows, right? And I'm going to create a job. Now, this is different than Delta Live tables, still a pipeline object, but this is based on tasks, and then we can create tasks and bring them together and create conditional arguments. So a task doesn't necessarily have to be something that's performing. It could be a way that, it could be a conditional statement to control flow. We're going to name the first task in this job, load baby names, just like the notebook is. And here's what I wanted to show you, and this is what makes this more robust from a use perspective than just Delta Live tables pipelines, because you can include those in here, but there's other things I can include like SQL commands, Python scripts, conditional statements, if-else conditionals for each to control flow, things of that nature. We're going to use notebooks for this one. By the way, if you have your notebooks in a GitHub repo, allows you to grab them from there as well. We're going to use the workspace ones. And then we're going to select a cluster. Now, I'm going to use my existing cluster because it started. I would have to wait for the job cluster to spin up before it could run this pipeline. So this one I'm going to run through this because it's already running, and I got a little bit of time before that particular cluster is going to terminate on me. So since it's up and running, this job should execute seamlessly once I get it done. I'm going to create the task here. Oop, I got to select notebook. This is going to be load baby names notebook, and then I'm going to create the task. And then just to show you the job details, there's some things that I can do. If I was connecting to a GitHub repo, I can add the settings to connect to it. I can also add triggers. So if I'm going to run this one manually, but obviously we could schedule this on an interval, right? Or based on if a file arrives, or I could just have it once the pipeline executes, it'll execute it again, maybe more for real-time purposes. Just know there might be some limitations on things you can and can't do based on the real-time part, some settings. I'm going to add a new task now. This is going to be a notebook-based one. And we'll call it filter baby names, because that's what we're going to be doing. This is going to be a notebook workspace object, and this is going to be the filter. Going to have it run off of my cluster. And this one I'm going to add parameters. So if you remember, this is going by year, right? So I'm going to add a year value, and then I'm going to set a default for 2014. I think the code already has that in there to do this, but we're just going to set that as it. But now I can change how I want this data filtered by setting that parameter object. So now you can see I have two steps in my pipeline here. It's very simple. We're just trying to get the points across here. I'm going to go ahead and navigate out of the details because I'm not going to set a schedule for this. I'm going to run it now. But you can also see that I have the option to run it with different parameters. So we'll go ahead and run this since I have my compute up. And once I have this running, now I can go into job runs, take a look inside, and you can see that my compute is up. And I can actually go into each task and see the progress that's happening with this. So right now it's executing the actual Python script that's in here. And if I go back to the run itself, this should show me some of the outputs that are being identified in here. Now that one's completed, so the data's been loaded, this one should provide me the output, the actual table output that's going to be generated from what we're doing with this sorting operation, right? Filtering down the data by a specified year. I can come back to that in a second while that's executing, but in my catalog, just to show you, it should have added into that volume that babynames.csv. So that's what I was hoping for. That's what it did. And now you can see that this step executed. You can see that the year here has all the 2014 information in it, none other. So now I know that this is executed properly. That's awesome, right? So let's go back into the job. And I can rename this job, by the way. I'll call it baby names demo. Oops. Wasn't trying to activate Copilot there. Must have hit a button. Baby names demo. And now we're going to run this again, but we're going to run this with different parameters, right? So you could see that the year is set for 2014. Let's set it for 2015. The new job is now running on my cluster. And keep in mind that you could use job clusters. This is an all-purpose one that I've created, but you can use job clusters. Just realize that if you're going to use one of their job clusters. It takes a little bit for it to spin up and then execute. Usually about, I've been seeing around 4 or 5 minutes for the job clusters to spin up. So if you want to have predefined clusters that are good to go and ready to go for your pipelines, you can utilize those as well. As your serverless or as your warehouse computes. Just keep in mind that your warehouse computes will only work with SQL. So be aware of that. Now the output should contain all the 2015 data. So this is the power parameters. I don't have to go in and change the notebook necessarily. All I have to do is change the parameter value because years here, right, that was the parameter I've changed. I'm telling it what to sort it by, right? So the default, it's going to create 2014 by default, but here we're actually setting 2015 as a year and overriding this parameter value here. So that will be 2015 in that case, and then we can utilize that for changing how we want the actual pipeline to run. So that puts a wrap on this particular case. We can call that one closed. I know it was a pretty simple example of a jobs pipeline, but hopefully you got a little bit more insight into how to create these, and let's head on back. As we wrap up our deep dive into Azure Databricks workflow jobs, it's clear that this powerful tool is the key to solving the intricate mysteries of data processing and analytics. From orchestrating and scheduling tasks to automating complex pipelines, Azure Databricks equips you with the capabilities to handle any data challenge with precision and efficiency. By integrating seamlessly with other Azure services, supporting real-time data processing, and ensuring scalability, these workflow jobs ensure your data operations run as smoothly as a well-planned detective operation. So whether you're chasing down data insights or piecing together the story from your data sources, Azure Databricks has you covered. Thanks for joining.